Open the ExpressMarine SSI tutorial.3dm file. You'll see a simple model with the shell, 2 decks, 3 longitudinal girders, 5 bulkheads, and several floors. Let us review how the model is organized. Shell surface, including transom and bulwark, is imported as a Rhino open polysurface, and you can see it in the ExpressMarine tree in the node structure, shell PS. As you can see, 7mm aluminium stock is used and the Generate Symmetric SB Objects option is turned on. Frames are defined as the attribute of the shell. Stock HP60x4 is chosen and frames are created, except of frames 6, 13, 20 and 30, where we'll have the bulkheads. The limits are frame -10 to frame 30 with an offset of 700mm, and they span from the deck 1 to the fixed height of 10 meters. Let us review the deck's definitions now. The lower deck, deck 1, is created at the fixed height of 0.5 meter and limited with starboard and portside shell. Thickness of the deck is set to 7mm and material to aluminium. The upper deck is defined at the fixed height of 2.47 meters and is made of 6mm aluminium. Beams, made of HP60x4, are created on the upper deck. Beams are defined on every frame from -3 to 50 with exception of frames 6, 13, 20, 30 and 38. Beams are limited by the shell with an 700mm offset at the aft and foreship. 5 bulkheads, made of 6mm aluminium stock, are defined at a fixed length of the specific frames. Stiffeners are created on each bulkhead, similar to the deck beams. Longitudinal girders are defined at the centerline and at 1.5 meter portside and starboard. In addition to the standard properties, we have cutouts in the girders. Cutouts are defined with the start and end and height position, spacing, cutout dimensions and radius. Finally, we have several floors in the model, defined between the bottom shell and lower deck. Most of them have stiffeners and cutouts. Now you know what the model consists of and what are the relations between the elements. The goal of the exercise is to see how the parametric objects behave in case one of them or several are changed. As an example, we'll modify the shape and replace the shell in the ExpressMarine model. Open the Hull PS3DM file. This is the original surface, which was imported to the ExpressMarine model and used for shell definition. We want to modify the surface and then replace it in the ExpressMarine model. Switch to the top viewport. Select the surface and scale it by 15% in the transverse direction. Save the drawing with the name Hull PS New. Open the ExpressMarine model. Select the shell surface. This will also select the corresponding node in the project tree. Now we will replace the current shell with the updated one. Click on Import Hull in the ExpressMarine window. Locate and choose the Hull PS New 3D file. You will see the existing current shape and imported new one. We need to generate the new shape. Click on Generate button. We'll hide the starboard part of the shell. Notice that the frames are regenerated as they are the attributes of the shell plate. Although, there is a gap between the shell and the deck, as well as between the shell and other structure elements. Objects need to be regenerated to adjust to the new shape. They can be regenerated one by one, selecting the specific object in the model or in the tree and clicking the Generate button. Or, the complete model can be regenerated in one go by clicking the Update Model button in the ExpressMarine window. As you can see, all the objects, having the port side and starboard shell as the limits, are regenerated and adjusted to the new shape.